Welcome to this talk on using ERLANG term storage to replace ElasticSearch features. I want to start just by asking a question. So raise your hands if you've got a search function in your app. You have users that search for stuff. Okay. Keep your hand up if your users really like the way it works. Okay, cool. New show of hands. How many of you have somebody building search full-time on your team? That's all they do is focus on search. Ooh, no hands. Oh, we got one over here. Yes. All right. So give me some shouts. What are people using to implement the search functionality?
ElasticSearch.
ElasticSearch. Anything else? I hear database. I hear what else? Algolia. Okay. I don't know what that is. Cool. So, my name is David Schainker. I work at Adobe on Adobe Fonts. You can find me on social media at Shanks, pretty much everywhere. And last weekend, I came in town early to try to enjoy the Rockies, and I tried to climb a 14er and failed because of electrolyte imbalance. So I decided I would fill my talk with salt and bananas so that we can climb the mountain together. Adobe Fonts is pretty cool. We're hiring. Come work for us. The Fonts team is awesome. And let's talk about features of ETS and libraries that you can utilize to build search functionality in your applications. When you browse fonts.adobe.com, this is what we have today. All of this is powered by ElasticSearch. We do not query the database, and our library is too big, so the database is really not an option for us to do searching. On the left here, we have filters that pull up subsets of our library based on typographic classification and typographic properties. Up top, this is a really standard search bar. We can autocomplete on names of fonts. We can search for foundries. We can search through descriptions, type designers. It's full text search with autocompletion in one. And I really like this UI, or this UX, because it's really simple. And because of the way we're using ElasticSearch, we can do a full search really quickly. This page will respond in milliseconds when you change your search terms. So these three features of ElasticSearch make it really useful for us on our team. We have filtering, autocompletion, full text search. If you're building a small to medium-sized application that does things like this with a library or a catalog that has lots of different terms and things you want to filter on, there's a good chance you'll need to implement these features somehow. And ElasticSearch is a totally good tool to reach for. So let me just briefly cover why we're using it, and then we'll talk more about ETS. ElasticSearch, written in Java, it's got Lucene inside of it. It's a really great search engine. And it also covers a lot of the other things that we need for handling data. We can index the system while we can index data while the system is answering queries. We can serve queries on newly indexed data. We can switch indices atomically, so we can make an update to our library and then make everyone start using it immediately, and there's no problems with that. ElasticSearch is distributed. So we are resilient to node failures, node disconnections, weird problems that can happen in distributed systems. And we answer queries in soft real time. Internally, ElasticSearch has this notion of tasks, which are threads. And then there's a scheduler that handles distributing work across the cluster. Does this sound a little bit familiar to some of us? So long term, this cluster is going to keep growing. We're going to keep using it. Our indices will grow as the library grows. We might get more users using it. If we need to add nodes, they synchronize automatically. And when nodes disappear, the cluster will just keep doing what it's doing without any trouble. When it comes to observability, knowing what's going on, ElasticSearch gives you a lot of great tools for that also. So we can also see how the cluster is doing when things are weird. We can keep an eye out for strange behaviors. Then disaster management is also really nice with ElasticSearch. They give you an API to snapshot, restore data. If things are really bad, you can get up and running pretty fast. One thing that's unique about workloads for smaller applications is that your data set might not be too big, but it might be too big for your DB. Right? ElasticSearch is really famous for handling tens of millions or billions of documents, terabytes of data. Like, there are all these great blog entries about people using ElasticSearch with really amazing and huge requirements. For us, our entire library can fit in memory, and that lets us query them really fast. So that's why we can do all of this soft real-time stuff. Ultimately, we treat it as a queryable cache, and it's really good for this. So what more could we ask for, right? Well, of course, with all things, there are costs, and I do want to cover some of those things. The DSL for ElasticSearch is pretty straightforward. The API is well documented. It's easy to learn. Once you kind of get used to using the API, then you'll probably find a library that's a client, and that actually might have a different DSL just because they're trying to be friendly to the language you're using. So now you might be learning two DSLs at the same time, but at least you're getting good. You're getting a good ability to see what's going on under the covers. Integrating with ElasticSearch is a challenge. You have to work hard to make it do what you want because, if it's your first time using a search engine, there's going to be a lot of new things to learn. It's not a hard learning curve. It's just there will be some trial and error. So you might spend time iterating on what works for your use. Running a really resilient search cluster can be expensive. People that run it, at really high scale, it costs money. You might not care. It depends. You can throw RAM, you can throw CPU, and your cluster will be more performant. That's fine. It just costs money. Version management in ElasticSearch has become easier. Previous versions sometimes had changes in their APIs, and the backwards compatibility would sometimes break. And so we had this issue of keeping up with new versions. If we're too busy building products, we might have to skip a version of ElasticSearch. But if you've been using older versions, like ElasticSearch 2, and you're bumping up to 6 or 7, there's some real big changes in there, and it actually might feel like you're rebuilding everything you did before from scratch. That costs time. Prior to ElasticSearch 7, some of the defaults were kind of weird. We are really glad they're addressing this. We found some really kind of crazy defaults with some of the ways that you build a distributed cluster. And I also got a little bit salty about the documentation about configuration. They're trying to push people to not configure stuff as much because they want you to just rely on defaults, which I think is a good idea, honestly. But when I couldn't find documented actual configuration parameters, I found somebody that grepped the whole code base and built a website that told you what the configuration things are and how they work, because apparently this wasn't like part of the official documentation. So yeah, I get a little nervous because I'm like, oh, am I doing something that's not right with my config? I don't really know. Like, I'm relying on a lot of other things that are not the official documentation to do what I need to do. So yeah, a little bit salty. I get that. Overall, ElasticSearch is really great. It works well. The free version works well. And your requirements for your app are different than maybe somebody else's. And the requirements are always dynamic and changing. So this could affect your product development. And for us, it's worked out really well. We really do like ElasticSearch. Interestingly, we also don't have anybody dedicated to doing search full time. We've been able to set up our cluster, let it do its thing, and it's pretty happy. We've heard of other teams that have actually many people keeping their cluster running. The Elasticsearch documentation buried in there somewhere, it says, Elasticsearch is a living, breathing animal. It requires care and love. And I'm like, well, that's nice, but I just want my computer to do what the computer does, and I don't know if I want to care and love for it that much. So this is not an Elasticsearch conference. This is ElixirConf. So let's look at some of these search features through the lens of ERLANG term storage. ERLANG term storage is batteries included to give you in-memory database functionality. So quick show of hands, who's using ETS right now in production? Awesome. How much do you spend on implementing new things in ETS? A lot of time? Not much time? No time at all. Oh, nice. Cool. Is there anybody here that has no clue what ETS is? Couple hands. Great, cool. Let's cover that real quick. So I think ETS is a little bit bananas. The first time I read about it, I was really, really surprised there's all this here. So in the functional world, we pass around state sequentially from process to process to compute outputs. Sometimes we need shared states somewhere that other processes can interact with concurrently. Likewise, what if we need to destructively update data? What if we don't want some piece of data garbage collected? What if we have something that we need to access from anywhere in our app? So ETS is built into OTP to handle these situations. Just call out to ERLANG from Elixir with the :ETS. With ETS, you store information in key value tuples. So we'll take a look at that in a little bit. As I mentioned, your data is far from garbage collection. So none of this data is destroyed unless the process that owns your ETS table terminates. But that's okay. Maybe that process terminated and you weren't ready for it to terminate. There are behaviors you can implement so you can pass ownership of that table to some other process. So you get some resiliency built in there. Data stored is concurrently accessible. Reads in particular are very concurrent, but they're serialized under the hood, which is fine. This is nice because updates are atomic. Things aren't going to change in strange ways all of a sudden. So yeah, I thought this was pretty cool. I was like, whoa, maybe we don't even need Redis anymore. So it's flexible. Not everything about ETS can be covered in this talk. And in terms of use cases that are really common, these four are definitely, I think, what apply to a lot of things. Since we're talking about queryable caching, I want to focus a little bit on cache data. We'll cover some bare bones ways to cover query cache data, and then we'll look at some libraries that also make that more user-friendly. So, ooh, there's music. So to guide implementations with ETS, I like to ask a few questions about our requirements. So in our case, where does data come from? For us, it's a transactional database. Our data set is different for most Elasticsearch implementations. It's not billions of documents. It's not terabytes of data. It fits in memory on a pretty modest machine. And once we index the data in, we're only reading it. The library doesn't change unless we want it to change. Data doesn't change that often either. We might make library updates every once in a while, 3 times a day, but it's not thousands of times per second or anything crazy like that. Not that that's crazy in a bad way. It's just, we're a little more laid back about our library updates. So how do we put structured data into ETS, which takes tuples? Is this a good idea? Let's bring our salt and find out. So back to Adobe Fonts. We have filters, the search bar, auto-completion, and full text search. So let's look at some filtering. Pretend you have a record like this coming out of your Ecto repository. So this is a font struct. It contains, in our example, the name of a font, the classification of that, the typographical classification, and then a description. So we will call ets.new. We'll give that table a name. And then we will say, what do these, what do the objects look like in that table? In our case, we're using sets, and we're using public access, so any process can read this. Sets in ETS give you one key per object, there's no order, and there's no duplicates. This is the default ETS table type. Oops, excuse me. After that, we'll put some data in, ets.insert, ignore this horrible typo on the third line. And then when you want to look up stuff, you can just call ets.lookup and pull out, in our case, font Futura, which is a sans serif. Ooh. What about filtering? We put data in, we pulled it out. If we want to filter it, we can use match to and match object 1. These are really useful functions. They give you exactly what you asked for. And this basically lets you filter stuff. I can say match for sans serif fonts, and I get back, in this case, Acumen and Futura. If I match object, I get a whole object back. But what's this weird $1 business here? Well, the variable number $1 business is the result position, but not the match position. So the syntax feels a little bit weird, but you kind of get used to it. For me, this then takes us to match specifications. This is an ERLANG term describing a small program that tries to match something. This basically lets you query data, and you can actually use a select command to pull results out. So you turn a query into a match specification, and then make query it in a way that's familiar, and it looks a little weird, so let's break it down. In this case, we make a function that takes these fields N, C, and D, which is just short for name, classification, description. And then we want to find all of the fonts with the classification sans serif. So we get 3 parts back when we make a match specification. The first part is the match head. This is the shape of our desired objects. The next are your conditions. This is how we're filtering. So you can actually see that we're saying what is equal to the second term in the object that has the value sans serif as a string. Finally, the match body, which is the format of your results return. In this case, we're only asking for the first entry of the tuple, which is just the name of the font. So then we call select, and we get back a result. One gotcha I learned about this approach is that if you have a compiled function compiled function from your code, and you try to call fun2ms on it while in an IEX shell, that's not going to work. Likewise, if you have a dynamic function and you try to send it over to compiled code, that's also not going to work. But wouldn't it be nice if we could maybe do some of this filtering from Ecto directly? I found out there's a community library for this. So a fellow community member in the UK, Evadne Wu, wrote a library called ETSO, and it treats ETS tables like Ecto repository structs. So one of the nice things about ETSO is you get a supervision tree for free that does really nice default implementations of resiliency. So you don't have to worry about building your supervision tree in a fancy way, just ETSO does it for you. And then we can still use match specifications inside of ETSO. So before we had this match spec, and now we can do something a little more familiar. We can just call out to Ecto repo, where classification is this, select it, and then get all entries from repo that match it. This library is still new. It's looking for people. Go check it out on GitHub. I put the link on the top of this slide. But I thought this was a really nifty way to deal with, I think, what is arguably a really good set of kind of basic stuff you want to be doing with ETS without having to use a lot of ETS. Okay, so that was filtering. Let's move on to autocomplete. For implementing autocomplete, I thought I would have to come up with something really crazy. I started learning about like Julia arrays and like tries again, and I was like, oh, all that like computer science stuff I did in school that I forgot, what is it? But ETS actually has internal functionality for this. Match specifications can match exact binary values. So you can return lists of results based on a string entered by a user. Turns out ETS has really efficient data structures for doing this. This example matches fonts containing serif in their classification. So Futura is sans serif, and Adobe Garamond is a serif font. So in this case, our match body gives us both. That's pretty cool. OK, so that went a little quicker than I expected. I thought I would have more. But we're just on to full text search already. And guess what? I'm going to be honest here. Full text search is a real gorilla in the room. It's big. I mean, what does that Google company do? They do search. Like, what were those search engines in the 90s? They do search. Like, this is ElasticSearch. They're publicly traded. They do search. It's a really big problem. So it turns out, digging around, there are a bunch of full text search libraries available in the community already. And the first one I thought was really cool. Elib1 was built by Joe Armstrong. He wanted to build something called an inverted index to allow you to do text search. So an inverted index basically takes a document and you build a table of which documents mention a given word. And then you can look up a list of matching documents based on a word. Then beyond that, you have some pretty heavy-hitting libraries. You could still learn to use Lucene. You could try to integrate it with your app. You could build something different. You could use Redis search. So that's a new tool from Redis where you can do full text search inside of Redis. And React also has a distributed search engine component built into it. So you could also do something with React to have full text searching with indexing and a lot of the out-of-the-box functionality that you would actually get with ElasticSearch. But of course, all of this stuff takes time to learn and use. And it really depends on your app and what you need as a team. Like a team of 10 people might have more resources dedicated to doing something like this than a team of 3. So that's a little bit of salt. Are you ready for a lot more salt? What about the real world? We've just covered using ETS for components of a search engine. That's not the whole thing. There's all these other things that stop us from making an Elasticsearch killer with ETS. Notably, there are some performance limitations in ETS that other people talked about today. Did anyone go to Miriam Penna's talk? Yeah? Cool. So in that talk, she mentioned that as your data structures get bigger and you put them in ETS, you can experience certain kinds of performance. And that's a real thing to think about. How big are these documents? Are you storing 3 fields or are you storing 1,000 fields? That will definitely impact the way that you think about building this component of your app. Most search engines include rankings. You search for something, you get back a list of ranks. We didn't even cover that. Multi-language support. Searching for typography in Asian languages requires different characteristics than Western languages. So think about your users. What UX do they need? If there are a lot of fields needed to represent information, we might need to store them somewhere else, or we might need to break out our indices. Adobe Fonts also has a pretty big font library, and we have a lot of business logic that we pipe through Elasticsearch. So it gives us flexibility to adapt to the business needs. So remember all those operational concerns I talked about, like self-healing infrastructure, nodes disappearing, coming back? We haven't really touched dealing with any of those things with ETS. ETS will be highly available if you architect your system the way you want. Data synchronization is out of the box. I haven't learned yet how to do that with ETS. So if, let's say, I'm trying to build a horizontally scalable cache, and I bring up a new node, how do I get a copy of that data from the old node to the new node so that they can both be serving the same data for requests? Elasticsearch also has this concept of index aliasing. ETS can do this as well. You can create a new index underneath a current index and then promote data upwards. So there's some references I'll have in my slides when I put them online that tell you a little bit more about doing this stuff. But wait, there's more. The most bananas thing I learned about for this was persistent term. It doesn't do any filtering, autocomplete, or text searching, but it's just a really supercharged key value store. You can access things in constant time really fast. It's been highly optimized for reading terms at the expense of writing and updating terms. A good thing to note is that if a persistent term is updated or deleted, the ERLANG VM is going to go through and do a garbage collection pass, look at which processes are using that data, and then copy it to those processes. That way, you can use persistent term for things that are frequently accessed, but very rarely, if ever, updated. So that was a bunch of salt and bananas. It got us up the mountain of learning more with ETS, and that's it for my talk today. Thanks for coming.